work on this concept for a minute. One of the keys to dilution, and just making simple samples, and you've done this before, but it's just such a simple idea, but I just want people to get it right, is, you know, I've got this glassware, maybe I'm going to use this pipette. It's fresh out of the box. These are plastic, so we always use a brand new one, but you still may feel uncomfortable. You might want to clean it out first. You have these volumetric flasks, you have a little beaker, you have ultimately you have the cuvettes as well. So I'm going to start with this cuvette first off, and we'll talk about cleaning it for a second. So it's one of the things to understand about these is they have a little bit of groove to them, and that's just to save volume. So I can put my finger in there because the light, the business end, doesn't pass through this little indentation. That's just to save volume. But the important part, and you can look at it if you kind of see, you can see there's a really nice square flat piece of glass that goes on the wide sides. That is the optical glass. So what happens is you have a fairly inexpensive, like a polycarbonate body, and then you put some optical glass or plastic pieces on the side, and that's where the money is. That's what you don't want to handle with your hands. And if you do have to clean them, you can just get regular lens cleaning paper. And that's just what you'd use on your glasses because it doesn't scuff them up. Some people use Kim wipes. I don't recommend that because the Kim wipes are a little rougher as far as going to glass. And anybody who wears glasses understands that because if you get something rough on your glasses, it kind of ruins that pair until you can get a new one. So we cleaned off the optical glass. So we'll keep that in mind when we're ready to run samples. So now let's talk about generally as you dilute, and then I'm going to give you a good idea here how you can do this. A little poetry for you. Okay, so here's the way I think of it. If I'm going to put what we call the mother solution. So the mother solution is the most concentrated solution. Everything below that would be the sons or daughters, right? The dilutions. But the mother solution is the most concentrated, and it gives way to the diluted offspring, so to speak. So, if you're just going to use the mother dilution directly, or if you have a pristine sample that's already prepared and you do not want to dilute it anymore, then what I say, if you're not going to dilute, then cleaning what you're going to put it into with solvent is pollution. It's not okay. On the other hand, if you're about to dilute the mother solution, then solvent is the route. So no dilution, solvent is pollution. Going to dilute, solvent is the route. That's the way I would say that. I'm kind of mispronouncing route, but it works for the poetry, I guess. Poetic license, that's what that is. All right, so here's what we're going to do. I'm going to take the one cuvette that I had actually just cleaned, and I'm going to just put some mother solution in there so I can look at the most concentrated. You can write on these cuvettes if you write up high, because like we just explained, this down here is where the business end is. All this up here will not show up. The light will not pass through any of this. The light actually passes through the bottom half. So I don't even have to fill solvent up above that half, where I just need to make sure I cover the optical glass. That's the key. So I'm going to mark that one M. And again, now I get to apply what I just said in that I'm like, okay, I'm just trying to put mother solution in there. So I'm not trying to dilute. So to pre-wash with water would be wrong, because I'll leave a little bit of drop of water in there, and that's going to dilute the mother solution I put in there. So this is the second one, or no dilution, solvent is pollution. So in that case, you just use the mother solution to rinse things out. Now, another thing is, you know, the whole class may be using this bottle, so I don't want to put something down in it and pollute it. So I'm going to use that same principle very quickly and going to go into this glass, give it a quick little shot. I can actually just rinse out this glass into my waste beaker. We give it another one. There you go. And I tilt it over, get it up on the sides. There you go. And now I actually have some other solution. Now do you follow that principle I just showed you where I said, hey, we're not going to dilute. So solvent would pollute. If I rinse with water, it would somehow dilute that. So I now know because I'm not diluting, right? Then the mother is the solution in that case, right? It's the way to do that. And so I can do that again in here in this little cuvette because I want to just get this pure solvent in there. That's all I want. So rinse with what you're about to put in there. And these, if they're already clean, you don't have to do this much. But again, that's almost, I only used about 1.5 mils just to get above that point. So that's good. So there's my mother solution. So there we go. So that's waste. So now I'm going to do a dilution. I'm going to do a 1 to 10 dilution, for example. All right, so here we go. I'm going to take 1 ml of the mother solution. So now this vial is good to go. And I'm going to dilute it to a total of 10 mils with water. I.e., I'm going to add 1 ml of mother solution, and I'm going to add 9 mils of water. So now the mistake a lot of students make is they add 1 mil, and then what they do is they measure out 9 mils, but there's no point because these volumetric flasks are very precise. They have a single line on here, and when you fill exactly to the mark, that's going to be 10. Now what we've learned with our graduated materials is we've learned when we have a graduated pipette or graduated cylinder, you know to use the last line that you see as accurate, then you go 1 mark beyond. So this one reads 5.1, 5.2, 5.3. So I would report 5.30. Now that's a problem here because there's only 1 line. So how do I know how precise that is? When I look on here, there's a plus or minus, and it says plus or minus 0.04. So now on that one, you can actually report this then as 10.00 when I get it directly to the mark. And the thinking there is it's very narrow up this neck. So if a lot of people, and this is actually what they do, is they do it by weight. They fill to the mark over and over and over, and they see where it varies. And this doesn't vary at 10. It doesn't vary, in other words, somebody measures in 10, someone measures 11, someone measures 9. It doesn't measure at 10.1. It measures at 10.00. That's why they have that plus or minus. And over the multiple measurements, what they saw, it ranged plus or minus 0.04. All right, so that's one of the keys to using these single line flasks is you have to have the precision mark to tell you how much. So again, I need exactly 1 mil of mother solution. So I'm not diluting in here. So if I want to rinse this out, again, if I used water, I would have a problem because I might dilute what's about to come in there next. So again, the key is, first off, it's probably clean because it's brand new and these are disposable. But what you do is you bring up a little bit of solvent. You can turn it sideways, and sometimes it helps to just remove this so the fluid moves. And then you can move that fluid up the nozzle and move it around and rinse inside there. And that's going to be good. Blow that out. The pipette man. And now the next trick of these is these are mass produced. They're fairly inexpensive. They're disposable. You can always get the cylinder produced correctly. It's the little tip that gets you because that's going to be inconsistent. So don't assume that this tip is part of the measurement. So if I want to deliver 1 mil, I'm not going to go to the 1 and spit it out because that's probably inconsistent in that little part. And you'll see that in a calibration curve. So what I do is I go above. In other words, I'll draw up to 2 and then release down to 1, and then I've definitely delivered from 2 to 1. That's exactly 1 mil. And if I go up to 3 and drop down to 2, it's no big deal. Key is I just go past. Okay, I don't want to return that back to the pristine mother solution there. So I can do that on here. These are nice because they have a really controlled arm. See if I can get that. I want to make sure I'm getting that in the picture. Okay, yeah. So I usually control it down to the mark with my thumb on that little really fine wheel. And I can get it right to the mark. I look at it level. I don't look when my head's above the line or below. I look straight across to the line. I get it down to 2. There you go. Then I'm going to drop it right into the volumetric flask. Drop it down to the 1. Sometimes I got to pick that up to see it really good. Right to the line. I touch off the edge on my way out. Put the waste in here. Now for storage, always make sure these stay upright. Don't let them lay on their side, because if you let them lay down, sometimes the fluid drops back up into this pipettement, and then that's going to put contaminants up in there. So now that's a mil. So now I'm going to dilute to the mark. Now at this point, remember, do here when you're diluting to the mark is you can rinse in a little any of the droplets that are along the side when you're diluting to the mark. So this is a good chance to get everything off the edge on the way down. And then when I'm getting to that last line, if I use this bottle, I'm going to overshoot. So sometimes what I do is just dilute with a little water. Again, I can rinse with that, rinse with what I'm about to put in there. It's kind of that thought there, right? Okay, now I'm going to add water to the mark. That's where this comes in. It's a good way to add right to the mark. Sideways on it. The idea is that the bottom of the meniscus comes right to the line. So it's probably a little hard to see that, but the bottom of the meniscus is right to the line. Okay. Then we have these caps. Sometimes I might even go one additional. Take a little bit of my Kim wipe and make sure if there's any water hanging up there, I get it out, because I don't want that to wash down in there when I'm turning this over. Now I'm ready to mix. So you either put parafilm or you can put these glass stoppers. You can invert and start going around. I usually do an inversion quarter turn, inversion quarter turn till you've got the full circle in. Make sure you get that all mixed up. That's another thing that students do from time to time, and I know it's a lot to remember, but sometimes they do all this, they do it exactly the mark, then they use it right away and it never had a chance to mix. So it's important that it mixes. Okay, so I'll keep track of this. Ready for a fresh one of these. Again, I'm going in here, so now I got to stop and think. I do not want this to dilute anymore, right? So no dilution. So if I rinse with water first, that's going to be pollution, right? What I want to rinse with is what I'm about to put in there. So the key is you got to think through, and that little poem helps sometimes. So I'm going to rinse with what I'm about to put in. And the other thing is, we saw earlier that, boy, it took very little of this. It took very little of this to fill up to the mark. So I'm good. Here we go. And now I'm ready. I can mark this. So that's it. If it was 1 molar to begin with, it is now 1/10 of a molar, and that's just a general generalization, when I go to do my data, I want to make sure I give all the significant digits. So let's talk about that real quick, but I'm going to clean off my glass right now so it's ready for a good run. So let's talk about significant digits. This is 10.00, right? We can think about this one. I now have measured 1 mil, then I got one more line, so I'm going to measure in 1.00. So this particular tool isn't very good for getting me, if I wanted 4 significant digits, I need a better tool. So this would be 1.00, and so that would control the significant figure, so I can't keep 4. So another plan would be to use a better tool this way. So this measures 1 mil in 1/100th. So this is even better. I get my other pipette, right? It fits on here. I can do a pre-rinse. I'm going to do that a little bit differently. Now, I missed this earlier, so I'm going to go through this again. Now, this glassware, I assumed it was clean earlier, but that's not always a good thing to do. So this is a great example. I am about to dilute a 1 to 10 in a 10 ml flask, and I'm going to dilute with water. So in this case, the solution is okay to wash with because I'm going to dilute with it anyway. This isn't the critical mark, so it's okay to rinse these out with water in that case. So here's the difference, right? I am going to dilute, right? So solvent is the root for rinsing. So here we go. I'm going to use the same principle. This uses so little fluid you can even pull that all the way up for a rinse. Which is kind of nice. Now I go past again. If I went right to the 1 mark and spit it out, or to the 0 mark and spit it all the way out, then I would be using that little that narrow part, and that's not consistent. So what I do is I go up past. This has a -1 mark on it. So I'll go right to that -1 mark. And that's great because you can see that fluid cleaning it out. Touch it off. Go right inside here. Make sure it drops in. And go right down to the 9, right? It's going to be on the 9 line. That way I go to a line. There's right to the line. I touch off the tip. Get rid of the waste. This one's gone. Here we go again. So now you see why it was okay to rinse with water, because I'm just going to put more water in anyway, right? Make sure I get close to the line. Here we go. I kept my water with my water here. That's good. Right to the line. Perfect. And you know, just a note on these again, you know, sometimes you want to clean those off, but they should be cleaned beforehand. We're all right. 2, 3, 4, 5. Let's get a good circle in there and we're good. Here we go. So now, again, I don't need to use it all. It's done. And this one I'm going to call 0.1 high quality. There you go. All right, now here's another issue that comes up. So we solved it once where now we have our digits back. Because the way I would read this every line here is 0.1, and then there's 10 between that, so it can actually read 0.10 with lines, so I get one more digit beyond that, so I added 1.0000. So I have 4 significant figures using this. I'm diluting it to 10.00, so that has 4 significant digits. So my new concentration literally has 4 significant digits in the answer. The other thing about dilution is, let's say that I want to get smaller than the 0.1. Now the problem is, if I'm not using the full 1, right, because I had 1.000, right, and I'm going to use something less, so let's just say I added 0.5 of this, I lost a significant digit, because I would be adding, out of this volume, I would be adding 0.500. Now I'm back to 3 significant digits. So how do you get around that? Even though this is the best tool I have in the house, this is one of the smallest, there's a trick. It's called the dilution of dilutions. So if I take this high quality mix, which is already diluted, and I then repeat it again, and just go 1 to 10, right? Then it's going to be 0.01, but I'm going to have the same 4 significant digits. So that's the trick called dilution of dilutions. So now if I'll take something out of here, so again, I'm going to just do that just to prove the point. Again, I'm going to think about this. Okay, I'm going to dilute with water. So if I'm diluting with water, dilution, then solvent is the solution or the root. So that's okay. I get my new pipette. I take my high quality mix. I have plenty to spare even on the rinse. That's good stuff. Go to the 0.1 mark. Deliver to 9. There it is. And go to my waste. Mark with water. Make sure I rinse, rinse, rinse on the side when I'm doing this. Okay. Sometimes it's really helpful to get that dropper right centered, because if you kind of surface tension will hang it up on the side sometimes. Okay, now again, if I have a little drips hanging up the sidewall above the line, I'll go in there with a little Kim wipe and grab those, because I don't want them mixing in and diluting above the line off the sidewall. By the way, if you have a lot of that, a lot of hanging up on the side, that just means your original volumetric flask was dirty. So if you clean a volumetric flask properly, it will literally, it won't have much hang on the glass. The glass is very clean, so it will release the fluids. And then another thing about that is you never dry these in an oven. So that's the other trick of this. So now what I've done, so what we got, well, probably shouldn't work over the other samples, because the minute I drop something in there, I ruined it all. Here we go, above the mark. Again, I don't have to fill very high. This guy is 0.01. And we're off to the races. All right. So I'm not going to do a full calibration set, but you see what's involved. The other thing you always need for your calibration set is you need a blank. Blank is a solvent. I'll explain that here in a minute when we get back on the instrument. I rinse this with water a few times. And there we go. This is my blank. And I'm ready to go. You, of course, would have all the samples prepped up, but I just want to give you the general ideas.